Hello everyone. Through this video we are going to discuss from question number 9 onwards in exercise 4.2 in the chapter of determinants. So in this type of questions we have to use properties of determinants to show that LHS is equal to RHS of the given expressions. So here is question number 9. So from this left hand side we shall try to derive the right hand side using properties of determinants. So coming to the proof part, so starting with the LHS. The LHS is this one: x, y, z, then x square, y square, z square, then after yz, then after zx, then after xy. So in this type of questions, our intention is to reduce the determinant to such forms in which the determinant can carry maximum number of zeros. So here in this case, for doing that, what we shall do, and our requirement is x minus y, y minus z on the right hand side. So in this case, the row or column, if suppose we proceed with row wise, in that case any one row out of these 3 rows we have to select, and then we have to perform addition or subtraction as per the requirement from in the other 2 rows. So means the row which is with respect to what the changes will occur, from that row no subtraction should be done. So here in this case I am choosing the first row, means while using properties what I shall write, R2 replaced by R2 minus R1 and R3 replaced by R3 minus R1. So I am choosing here the first row with respect to what the changes will occur in R2 and R3, row 2 and row 3. So the row which I am considering should be kept as it is in its own position. The rest of the rows, there will be changes. So here I get y minus x. I am subtracting the corresponding elements of first row from the second row, and this replacement is done in the second row itself. Y square minus x square, then zx minus yz. Then in the third row I shall be getting z minus x, then after z square minus x square, then after xy minus yz. So this is the second step. So after this, as per the requirement of the right hand side, we can consider the element x minus y along the rows. Let us check in what way the changes, common term can be taken out. X, here it is x square, then here it is yz. I can take common minus here, then within the bracket this will be left. Then here in this case again there will be changes like this, where if minus is taken common, then after in this part z can be taken common, and within bracket x minus y will be there. Same is the case with the third row also. Our requirement is x minus z, and according to that, on the right hand side our requirement is z minus x, therefore it has to be kept as it is so that we can take common directly. So keeping this as it is, what can we do? Z minus x I kept as it is, and from this part again z square minus x square. In the last part I can take common minus y so that I get back z minus x. Then after we can take common the terms along second row and the third row. We can take common x minus y and z minus x. What will be left within the determinant? X, it will be x square, then after yz, then after here what is left? Minus 1, then after minus x plus y, then after z is left, then after 1, then after what is left? Z plus x is left, Then after I get here minus y when taken common. So after that we find that actually we should try to get maximum number of zeros along any row or column. So here in this case there is an option. If I replace R3 by R3 plus R2, in that case this term can be 0. So taking these two terms as it is, z minus x, what change I shall make here? R3 replaced by R3 plus R2. So corresponding changes are x, x square, here it is yz, then this is minus 1, then this is x plus y, then z. Here in this case, if we sum up these two rows in place of R3, this will be 0. Then if these two terms, if this term and this term are summed up for this place in R3, so there will be only this term left, y minus z, and in this place there will be y minus z again. So these are the results of this step where we did R3 plus R2 for R3. So after this we can find that these two terms y minus z is common along R3. So this can be taken out, as this is also a requirement for the RHS. So y minus z is taken out, z minus x is also taken out. So what are the things left? X, x square, then yz, then here it is minus 1, then it is minus 1, not minus 1, this will remain as it is, x plus y, then after z, then 0, this is minus 1, again this is minus 1. So after this there is possibility that along this row we can get maximum number of zeros if R2 replaced by R2 minus R3, then minus 1 plus 1 in this part will turn 0. So in the next step we can write x minus y, then y minus z, then z minus x. So after this what do we get? I have to write C2 replaced by C2 minus C3. In that case these changes will occur. X, then x square minus yz, then after this third column will remain as it is, then minus 1, here one more thing will be getting added like this, then after in this part z will remain as it is, in this part 0, here it is 0, and in this part it is minus 1. Then after we can perform expansion along R3. When expanded along R3, what shall I get? X minus y whole into y minus z whole into z minus x. When expanding along R3, for this term the result will be 0, then followed by this second term. Here also everything will turn 0. The left term is minus 1. With this determinant of these four terms will have to be taken into consideration, so that the terms come like this: minus x into x plus y plus z, then after minus minus plus it will be x square minus yz. So here I shall write expanding along R3, expanding along R3. So after this what do I get? I shall be getting x minus y, then y minus z, then after z minus x, within the bracket there will be minus within the bracket minus x square minus xy, then minus zx plus x square, then after minus yz. So minus x square plus x square got cancelled. All the rest of the terms will turn positive because minus sign is there outside. So x minus y, then y minus z, then after z minus x whole into xy plus yz plus zx, and this is the required right hand side. So this is the complete solution of. So next, this is question number 10. Question number 10, the first one, we have to prove that x plus 4, here in this case it is twice x, here it is twice x, then after again twice x, the second term we get as x plus 4, then the third term is twice x, then after again I get here twice x, then after twice x, then after x plus 4. The result comes as 5x plus 4 whole into 4 minus x whole thing square. So we shall start with the proof part. In the proof part, the LHS we have to start with. The LHS, let's write it once again. X plus 4, then twice x, then twice x. Then after twice x, twice x. Here in this case x plus 4. Here we get twice x, then after twice x, then after x plus 4. Now our basic requirement is this one, 5x plus 4 we should get. In what way can we get? Suppose if I want to replace R1 by R1 plus R2 plus R3, then in that case if we sum up all these 3 rows along the first row only, then we should get twice x plus twice x plus x. It will be 5x plus 4. In this case also x plus twice x plus x plus twice x, it will be 5x plus 4. Along the means the elements of the third column, if we add row wise, it will be x plus twice x plus twice x, it will be 5x plus 4. So that's what we need to do in the next step. In the next step we shall be following this property. In place of R1 we shall be writing R1 plus R2 plus R3. And let's check what we get. Of course 5x plus 4 will be the first element. Along the first row the second element will again be 5x plus 4, and third element along the first row will again be 5x plus 4. Now what are the elements left along the second row? This will remain as it is, nothing, no changes will occur here. So this is twice x, then twice x, then this is x plus 4 here. Then after along the first row we can take common 5x plus 4, because along the first row we find only one common term, that is 5x plus 4. When 5x plus 4 is taken out, there will be 1 and 1 left behind. Twice x, then after x plus 4, then after we get here twice x, then after here again twice x, then after twice x, then after x plus 4. So since along the first row there are 3 ones, so if we proceed column wise now, if we apply properties column wise now, there is possibility of getting maximum number of zeros along the first row and reducing it to the lowest form, that is like 0 0 1 or 1 0 0. In that form if we try to reduce, in that case result will be easily obtained. So in the next case what we shall do, we shall perform this this operation, C1 getting replaced by C1 minus C3. At the same time C2 will be getting replaced by C2 minus C3, means with which the column with which these changes will occur in C1 and C2, that is C3, will remain as it is, nothing to change here. Now so 5x plus 4, here we can write when C1 is replaced by C1 minus C3, 1 minus 1, the result comes as 0, then twice x minus twice x minus twice x, the result will come as 0, then twice x minus x plus 4, the result will come as x minus 4. After that Along C2, actually we are going to write C2 minus C3. So here in this case again 0, then x plus 4 minus twice x, the result will come as 4 minus x it will be, and in this case again the result will be x minus 4. The third column will remain as it is, like 1 twice x, then x plus 4. After this, as per our requirement, what is required in the right hand side in our question? In the question it is very clear that 4 minus x, this term is required. So while taking common, we should be very careful which term is to take common. So here in this case, if possible, we shall try to make all x minus 4 should be converted into 4 minus x. If we do like that, then in what way can we place the terms inside the determinant? Let's check once. 0, 0, minus is taken out, 4 minus x can be kept here, then 0, it will be 4 minus x, again minus can be taken common, 4 minus x here, then 1, then after twice x, then after x plus 4. So from the first column and second column we can take common 4 minus x. So from the first column 4 minus x I am going to take out, and from the second column also I am going to take out 4 minus x. So let us check how many we shall be getting. 2 4 minus x terms at a time we are taking out. So the remaining terms will be like this: 0, 0, then 0, 0, it is 1, then after 0, 0, 1, then after here it is 0, 1, it is twice x, then minus 1 is left, then again minus 1 is left, then x plus 4. So we find that row 1 contains maximum number of zeros. That is why expansion should be made along row 1. So I get here 5x plus 4, then 4 minus x whole square. Expanding along row 1, we shall be getting 1 multiplied with 1 into 0. It is minus 1 into 0, it will be 0. Then minus minus plus, these two terms when multiplied will be, result will be 1. So ultimately this is the answer I am getting, because from the bracketed part you will be getting only result as 1. So it will be expanding along R1. So what we shall get? Of course 5x plus 4 whole into 4 minus x whole square. So this is the required right hand side. That's the answer. Then coming to question number 10 Roman 2. Question number 10 Roman 2. Here the question is, actually this is almost similar to the first question of question number 10. So the terms are y plus k, then y, then after y, then after I am getting y, then after that y plus k, then after the next term comes as y, then after y, here it is y, then after y plus k. The results will be like this: k square within the bracket thrice y plus k. So this to get this result on the right hand side, we find that this is a term thrice y plus k. Thrice y plus k can be obtained if I replace like the previous sum, if I replace r1 by r1 plus r2 plus r3, in that case this can be obtained. So let us proceed with that. This is the proof part. Starting with the LHS. LHS is this. LHS is equal to y plus k. Here it is y. Here again this is y. Then after y. Then after y plus k. Then after I get y. Then y. Here again it is y. Then after y plus k. So after this, while using properties, when we shall use properties, then we shall be getting this property. I am going to use r1 replaced by r1 plus r2 plus r3. Using this property, let us check what we get. So after adding r1 plus r2 plus r3, I mean if I replace r1 by r2, r1 plus r2 plus r3, then I shall be getting along the first row these three terms I am going to get, thrice y plus k, then here again thrice y plus k. The rest of the rows will remain as it is. There is nothing to change. Y plus k, then y here, then after y, then after again y, then after I get here y plus k. So it is very clear that from the first row we can take common thrice y plus k. Thrice y plus k can be taken common. So along the first row only these terms will be left behind. So we get y, then after y plus k, then after y, then after what do you get? Y, then y plus k. Since there are 3 ones along the first row, so there is maximum possibility of getting maximum number of zeros along that row only if we perform the operations column wise. So we prefer to proceed like the previous sum only. So in this case also I am going to replace C1 by C1 minus C3 and C2 at the same time C2 by C2 minus C3. So let's proceed. So thrice y plus k, I get here C1 replaced by C1 minus C3, at the same time C2 replaced by C2 minus C3. So I get here 1 minus 1, the result comes as 0. These two columns we are choosing first. Then y minus y, it will be 0 again. Then y minus k, the result will come as minus k. At the same time C2 replaced by C2 minus C3 means this one and this one we have to choose. So after making subtraction we shall be getting 0 here, then only k is left. Then after subtraction we shall be getting minus k along this column. So after that 1 means the third column is to be kept as it is, no need to make any change here. So expanding along, since R1 contains maximum number of zeros, so we can expand along the first row. So 3y plus k, expanding along the first row we shall be getting 1 gets multiplied with determinant of these 4 terms, because the rest of the terms will automatically turn 0, and this multiplied by the required determinant will be 0, this again multiplied by the required determinant will be 0, only this one is left which is valid. So here in this case the result will 0 into minus k will be 0 only. Then we can write here minus plus, it will be k square. So ultimately this is the requirement. We shall write here expanding along R1, expanding along R1. So this is the result we are getting. So we shall get k square thrice y plus k. So this is the required right hand side. So these are the solutions of question number 9 and 10 of this exercise. Thank you.